Okay, welcome back. What I want to do is continue with Unit 307, okay? And here we have Session 8, Live Testing 1, okay? Now, what we hope to show you here is the process that's been applied for testing, especially in regards to the earth loop impedance test, okay? Now, you need to make sure that you're compliant with the IEE regs, stroke IET regulations, okay? Irrespective of which edition is in play at that point in time. Currently, it is the 18th edition of the IEE regulations. Okay, this is revision for us. Okay, and this is what you'll need to be aware of and what we're going to be looking at. Now again, here we are in this session. Just to state the procedure for confirming polarity, specify the methods for measuring earth electrode, etc. Installation forming part of a TT system, earth unit generators and transformers, describe common earth fault loop paths, state the method of verifying protection by automatic disconnection of supply. Okay. Now again, I don't want to spend a lot of time talking on this because you're familiar with this already. Confirming polarity at the incoming supply. Okay. Now here we are quite clear that the polarity needs to be checked at the incoming supply because the distributor can sometimes get the neutral and the line conductors the wrong way around. Okay. This check is very simple and only requires a suitable voltage indicator such as the Martindale tester. Okay. Now the minus 6% here is the allowable voltage drop. Okay, basically. And here we're looking at earth electrode. Now, metal pipes of the water mains were used as earth electrodes, but this practice is not done anymore as they cannot be relied upon as plastic pipes are becoming the norm. Okay, and I think I've mentioned this sometime earlier as well. And here we have the requirements for testing. Okay, and again BS 7671. I'm not going to read this to you. You're capable of reading this for yourselves, okay, and implementing it at your discretion. Now, electrode testing using an earth loop impedance tester. Installation is a part of a TC system and has an RCD protecting it, then an earth loop impedance tester can be used. Okay. Now, I'm not going to take this through with you, but make sure that this is your earth electrode in regards to a TC system. And some cases you need to make sure that you've got a good earthing and that the earthing from the board to your electrode falls within a given parameter. Okay, and that is important for you to understand that. Okay. Okay. And again here we have the earth electrode test second method, and you can see here that various distances of the electrode have been moved around to get the best earthing possible. Okay. Okay, so that is bear that in mind. You may well need to move it, and plus you may need to drive it further into the ground. Now remember also that the resistance when it's wet in comparison to when it's dry will also be different. Make sure you get it all in carefully in view. Okay. Animals. Right, now in regard to this, animals are very susceptible to low values of voltage. Okay, so what you need to be sure of is that the earthing conductor is properly earthed and has a good foundation in regards to earthing. Okay, let me just take this into you. Right now, all we're saying here is that it is possible for voltage to occur or to appear between the front legs of a cow or a horse for that matter and the back legs, which can create a potential difference causing death to the animal. It is your job to make sure that this does not happen. So your earthing must be sound. And again, here we have maximum values of the earth electrode resistance depend on two key factors. These are the relative sorry, the rated residual operating current rating of the RCD, the permitted reference voltage regulation for W1.5.3. Now, make sure that this regulation is still applicable in the new regs, or whichever regulation you is compliant to. At this moment in time, it is the 18th edition of the IEE/IET regulations, or put that the other way around if you prefer. Okay, just to make sure you can read. Now you need to read this for yourself and make sure you are compliant with the regulations as it is. Okay, that is your job. Get it done. And here we are simply looking at verifying the test results. Okay, remember that each type of RCD now be aware that this table, these values here are not quite right. Okay, so you need to make sure that you're compliant with the regulation as it stands. And it says here, it tells you here, what these values are of no use to us, however, because they're too high, they exceed the recommended value. But it's just to show you as illustration how easily it is to get into a situation where the resistance, earthing resistance, is too high. Okay, therefore you have to make sure that you're testing and that your values are low enough to meet the safety aspects as per the 18th edition. And here it gives clear specification as to how the earthing electrode resistance can be improved, and that is what you're looking to try and make sure that your earthing resistance has a low resistance path as possible, to make sure that that current is taken away down to ground and that your safety device will operate. And again here you look at the same criteria in regards to earthing for transformers and generators. Here you can read this for yourselves. I will not be reading this out to you. Okay. And here we're looking at the earthing impedance test for your information. Take that out to read it for yourselves. Thank you. Okay. And here we have a look at the TNS supply system. Okay. Now this is your earth loop path. Okay, and you need to be familiar with that in regards to R1 and R2. Okay, let me just pan back a little bit and make sure we can get this in. Okay, yes we can. Now I'm not going to, there's nothing here for me to say other than you now need to do your own work on this. Look at how it's been done. Look at the tin supply system. Look at how the earthing has been brought in, and you'll find that the earthing is here. Okay. Your neutral conductor is a bar. Okay. Now notice that there's no earthing at your meter. It's not required, but it is required at your distribution consumer unit. Okay. I better bring this in a bit closer, I suppose. Okay. And let me just bring it back up a bit. Okay. 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 Thank you. Good. TNCS supply system. Okay. And again, it's showing you the earthing process. And again, for your edification, make sure you are familiar with this place. Okay. Okay. Let's just get you back up. Give me for a moment. Thank you. Good. Okay. And this is the TC supply system. Again, the system has no earth provided by the distributor. So this again is where you bring in your earth electrode comes into play. And that's very important. let me bring in here. Test point for fault loop impedance testing, and these are showing you where you can test these items basically to make sure that you've got the right earthing protection in place. Okay. Sorry. It's okay, I was just looking at the list I needed to go and make today. Got some grass seeds for the garden, that is. And it shows you here again how to use these different leads instruments. Okay. Okay. I must admit, I'm quite pleased actually with the way the diagram has come out, and I'm quite chuffed about that. Now again here you just perform a loop impedance test. Okay, basically. And again, look at the formulas at below here, which is down here. Okay. And that's the formula you will need to apply to calculate the values of such. Okay. Okay, let me just go back up, come back, pan out, I should say. Okay. Again, here I don't need to do a lot of talking on this because you should now be familiar with this, a lot of this yourselves. Okay. And here's some additional information. Confirming measure test results, okay. And again here, that's for you to read. I don't need to read this out to you. You're big boys and girls now, okay. That's your role. Pan back, okay. Make sure we got it in view. And again, Okay. And this gives you a rule of thumb explanation and what it actually infers. Okay. And here you have a couple of examples. Z is from the table is 1.09 ohms, that is measured is 0.08. And here you have your calculation being done for you. Okay, 1.09, which is here, okay, times 0.080, which is here, okay, equals 0.872 ohms, okay. You then have to determine whether or not this value is acceptable as such. And as you can see here, it is acceptable, okay, it is. And yes, this is less than this, okay. Okay. Make sure you understand this concept because you will need to apply it for yourselves at all times. Okay, let's just go back a little bit, make sure we can get this in play. Okay. So okay, I seem to have drifted off my angle. Okay, here it's giving you information as to what problems might occur in regards to the earth loop test. But it's up to you to make sure that you understand and you're compliant with the IET/IEE regulations. And this is just telling you the operating speed of our CDs, whether or not the approximation of operation. Okay. And I would strongly recommend revise the PowerPoint slides, work through them for your own benefit. Okay, now thank you for looking and listening, and I hope that you will found this quite useful. Take care, have a good day, bye bye.